We shall continue problems on DTFT. The problem is find discrete time Fourier transform of x of n equals a to the power magnitude of n. Sketch amplitude and phase spectra. Solution. X of n is an even signal here, so I will plot x of n, which you have done earlier also. X axis is n, y axis is x of n. Is n equal to 0, 1, 2, 3, minus 1, minus 2, minus 3. At n equal to 0, the value is 1. At n equal to 1 and minus 1, what is the value? The value is, in the condition here, mod a less than 1. So when n equals plus minus 1, the value is a. When n equals plus minus 2, the value is a square. When n equals plus minus 3, the value is a cube. This part of the signal is defined by the expression x1 of n is equal to a to the power n. From n equal to 0 to n equal to infinity. This is the expression for n greater equal to 0. From n equal to minus 1 to minus infinity, we define it by x of n will be called x2 of n equals a to the power minus n. This is for n less than or equal to minus 1. N less than or equal to minus 1 is same as n less than 0. So x of n is x1 of n plus x2 of n. The solution starts now by referring to this figure. We know that x of e power j omega equals summation n equals minus infinity to plus infinity x of n into e to the power minus j omega n. Please note that this x of n has all real samples, therefore it's a real signal. It's also an even signal. DTFT of a real signal which is even is purely real. What I am going to say is note. This note is very important. DTFT of a real and even signal. Real and even signal is purely real. It has no imaginary content in it. Very important note. I'll come back to this now. X of e power j omega by definition is summation n equals minus infinity to plus infinity x of n into e power minus j omega. And this implies x of e power j omega equals summation n equals minus infinity to minus 1. X of n is what? x2 of n. And what is the value? What is the expression? A to the power minus n e to the power minus j omega n plus summation n equal to 0 to infinity. What is x of n? x1 of n. What is the expression for x1 of n? A to the power n into e to the power minus j omega n. In the first summation, put n equal to minus n. The objective is to make the summation limits positive. When n equals minus infinity, what is m? Plus infinity. When n is minus 1, what is m? Plus infinity. Then, what we get? X of e power j omega equals summation m equals infinity to 1 a to the power m into e to the power j omega m plus summation n equals 0 to infinity a to the power n e to the power minus j omega n. will interchange the summation limits. That will not affect the sanctity of the equation. Summation m equals 1 to infinity a into e to the power j omega whole to the power m plus summation n equal to 0 to infinity a into e to the power minus j omega whole to the power n. Now we have to evaluate these two summations, for which we require this formula. Recall formulae. First one, summation n equal to 0 to infinity b to the power n equals 1 over 1 minus b, provided mod b is less than 1. Second one is summation n equals n naught to infinity b to the power n equals b to the power n naught by 1 minus b, provided mod b is less than 1. This formula, second formula I will use for the first summation. First recall I will use for the second summation. That gives us now x of e power j omega equals, what is b? This is b. So you get a into e to the power j omega divided by 1 minus a into e to the power j omega plus 1 over 1 minus, this is b now, a into e to the power minus j omega. Take LCM. If you take LCM, multiply this with this. So what you get? A into e to the power j omega minus a square. This gets multiplied by this. Plus 1 minus a into e to the power minus j omega divided by 1 minus, this is plus. Okay. These two will cancel out. Denominator you multiply the LCM. So what you get? 1 minus a e to the power minus j omega minus a e to the power j omega plus a square. So I have taken LCM and this is the simplified version. This implies x of e power j omega is equal to, numerator will become 1 minus a square, denominator 1 minus. Between these two I will take a common, then we get e to the power j omega plus e to the power minus j omega plus a square. Divide this by 2, multiply this by 2. This is like e to the power j theta plus e to the power minus j theta by 2, which is nothing but cos theta. So this becomes 1 minus a square divided by 1 minus 2a cos omega plus a square. See, x of e power j omega is purely real. This is in agreement with what I told. X of n was a real signal, also it was an even signal. Therefore, its DTFT has no imaginary content. It has got only real content. Now we have to plot it. Now we have to plot the spectrum. For plotting the spectrum, prepare a table for plotting amplitude spectrum and phase spectrum. We take values of omega from minus pi to plus pi. Minus pi, 0. Minus pi by 2, 0, plus pi by 2, pi. Here I write x of e power j omega. Then I write magnitude of x of e power j omega. Then we write theta of omega. Now when you put omega equal to minus pi in this expression, what we get? X of e power j omega when omega equal to pi. This is a note. When omega equal to pi becomes 1 minus a square divided by 1 minus 2a cos of pi plus a square. Cos pi is minus 1. Therefore, denominator becomes 1 plus 2a plus a square, which means 1 plus a whole square. 1 minus a square is 1 minus a into 1 plus a divided by 1 plus a whole square. So 1 plus a cancels out, that gives you 1 minus a by 1 plus a. So I write here 1 minus a divided by 1 plus a. When you put plus pi also, you get the same expression. So I write here 1 minus a by 1 plus a. Next, if you put here pi by 2 or minus pi by 2, cos of plus minus pi by 2 is 0, this term will vanish. So you get here 1 minus a square divided by 1 plus a square. This is 1 minus a square divided by 1 plus a square. Next we'll put omega equal to 0. X of e power j omega evaluated at omega equal to 0 gives cos 0 is 1. Therefore, denominator becomes 1 minus a whole square. So 1 minus a square is what? 1 minus a into 1 plus a. 1 minus a divided by 1 minus a whole square. So you get 1 plus a by 1 minus a. So I write that value here, 1 plus a by 1 minus a. In the problem, mod a is less than 1. That means a is, if you take any value of a, let us say 0.2 or minus 0.2 and evaluate all these expressions, you will get positive result only, positive number only. What is magnitude of a positive number? Number itself. Therefore, magnitude of x of e power j omega is same as x of e power j omega. So I write here 1 minus a by 1 plus a, 1 minus a square divided by 1 plus a square, 1 plus a divided by 1 minus a, 1 minus a square divided by 1 plus a square, 1 minus a divided by 1 plus a. I repeat this once again. Since mod a is less than 1, you take any value of mod a less than 1 and substitute here. For example, put a is equal to plus 0.9 or minus 0.9 and evaluate all these value expressions, you will get a positive real number. Therefore, its magnitude is same as the number. What is the angle of a positive real number? 0. Therefore, all these angles are 0. This means phase spectrum, this implies phase spectrum is a null spectrum. Phase spectrum is a null spectrum. Phase spectrum is a null spectrum. Now I am going to plot the amplitude spectrum. X-axis is omega, y-axis is magnitude of x of e power j omega. When omega is 0, it is 0. When omega is 0, what is the value? The value is 1 plus a divided by 1 minus a. When omega is plus minus pi by 2, when omega is plus minus pi by 2, what are the values? The values are, the two values are identical because of even symmetry. 1 minus a square divided by 1 plus a square. When omega is pi and minus pi, again the values are identical. What is that value? 1 minus a divided by 1 plus a. All these points you connect by a smooth curve that gives you amplitude spectrum. At omega equal to 0, the value is not 0, it is 1 plus a by 1 minus a. So 1 plus a by 1 minus a is greater than 1 minus a by 1 plus a because mod a is less than 1. This spectrum exhibits even symmetry. This spectrum is periodic with the fundamental period is equal to 2 pi. And this figure represents amplitude spectrum. Phase spectrum is a null spectrum. Phase spectrum is a null spectrum. This is how this problem x of n equal to a to the power mod n is solved. Very important problem, concentrate. Next problem. Find DTFT of x of n equal to delta of 6 minus 3n. Delta of 6 minus 3n. Also sketch amplitude and phase spectra. Also sketch amplitude and phase spectra. Solution. We know that x of e power j omega by definition is summation n equals minus infinity to plus infinity x of n into e to the power minus j omega n. What is x of n? Delta of 6 minus 3n. Substitute that. Hence, x of e power j omega is equal to summation n equals minus infinity to plus infinity delta of 6 minus 3n into e to the power minus j omega n. We have to apply shifting property. Where this impulse is located? That is found by equating 6 minus 3n equal to 0 gives, I'll write a note, 6 minus 3n equal to 0 gives the location of delta of 6 minus 3n. That means this impulse is located at n equal to 2. If you apply shifting property, e to the power minus j omega n gets evaluated at n equal to 2. That gives us e power minus j2 omega. I have applied shifting property. So what is important over here is to know the location of this impulse. To know the location of this impulse, the quantity inside the brackets of the impulse function is equated to 0. That means 6 minus 3n equal to 0 gives you n equal to 2. Hence, e power minus j omega n is evaluated at n equal to 2. That gives us this result. So this implies what is magnitude of x of e power j omega? Magnitude of this exponential is 1. Again, I want to note. What is e power minus j theta? E power minus j theta is cos theta minus j sin theta. This implies what is magnitude of e power minus j theta? Nothing but square root of real part square plus imaginary part square, which gives us 1. Hence, we can write e to the power minus j theta as magnitude equal to 1, angle equal to minus theta. Same logic here. This is like e to the power minus j2 omega. So what is the magnitude? 1. And what is the angle? Angle is coefficient of j. What it is? Minus 2 omega. Now using this expression, I will sketch the magnitude spectrum. Using this expression, I will sketch the phase spectrum, which I am going to write now. Magnitude spectrum. X-axis is omega. Y-axis is magnitude of x of e power j omega. What is the magnitude? Magnitude is 1. From minus pi to plus pi, all the spectrum, amplitude spectrum, phase spectrum, etc. plotted for omega varying from minus pi to plus pi or 0 to 2 pi. This is again, I write periodic. Fundamental period is equal to 2 pi. Phase spectrum appears like this. So what is theta of omega? Theta of omega, note, theta of omega is minus 2 omega. Compare with y equal to mx. What is y? What we compare with y equal to mx and plot. What is y? Theta of omega. What is x? Omega. What is m? Minus 2. Therefore, with minus pi and plus pi, you have a straight line passing through the origin. What is slope of this line? Slope of this line is minus 2. And what is the equation of this straight line? What is theta of omega? Theta of omega, equation of the straight line is, theta of omega is equal to minus 2 omega. This is pi, this is minus pi. When omega is minus pi, what you get here? You get 2 pi. When omega is plus pi, what is this amplitude? Minus 2 pi. This is phase spectrum. This exhibits odd symmetry. This is magnitude spectrum or amplitude spectrum. This exhibits even symmetry. Even this figure is periodic. As I said earlier, fundamental period is equal to 2 pi. So this is how we find DTFT of this impulse function, plot its amplitude spectrum and then plot its phase spectrum. Amplitude spectrum, since I again repeat, amplitude spectrum exhibits even symmetry, phase spectrum exhibits odd symmetry. This is true only when x of n is a real valued function. Next problem. Using properties, find DTFT of x of n equal to half to the power n into u. Solution. What is the quantity inside the brackets of u? N minus 2. Therefore, we have to ensure that the power of half also is n minus 2. Therefore, I will rewrite x of n as follows. X of n equals half to the power n minus 1 into, half to the power n minus 2, this is half square. Half square into half to the power n minus 2 is nothing but half to the power n into u of n minus 2. Recall, a to the power n into u of n has a discrete time Fourier transform 1 over 1 minus a into e to the power minus j omega. If you want to remember this result, it's like this. But this result, see, I will correlate with that of z transform. A to the power n into u of n has a z transform. Z divided by z minus a equals 1 over 1 minus a into z to the power minus 1, provided the RO says mod z greater than mod a. In this expression, if you put z equals e power j omega, you get this expression. However, that substitution is possible only when the ROC contains unit circle. This is only for your inference. How to remember this expression? In fact, this is the first problem we did. Hence, x1 of n equals half to the power n into u of n has a discrete time Fourier transform. x1 of e power j omega equals 1 over 1 minus half into e power minus j omega. Next, we'll apply time shift property. Applying time shift property. applying time shift property we get. I will call this entire thing as x2 of n. What is x2 of n? x1 of n minus 2. Applying linear shift property we get. Kindly concentrate. x2 of n is equal to x1 of n minus 2. We'll have a DTFT. x2 of e power j omega equals e to the power minus j2 omega into x1 of e power j omega equals e to the power minus j2 omega into 1 over 1 minus half into e power minus j omega. What is x of n? Half square into x2 of n. Applying linearity property, we get x of n is equal to half square means 1 by 4 into x2 of n will have a discrete time Fourier transform x of e power j omega equals 1 by 4 into x2 of e power j omega equals 1 by 4 into e to the power minus j2 omega divided by 1 minus half into e power minus j omega. With this, we conclude this session. Thank you.